Hello guys, this is a video of more progress on OptiDoom, trying to optimize various parts. I haven't focused yet on the main part, which is the seg loop, the whole seg loop. And I was curious about some things in the polygon engine, as I was profiling parts in the whole polygons, where I kind of replaced the whole columns with the polygons, which when I implemented back in time, it was a bit disappointing because I had to do extra stuff, subdivide very tall walls, as the cell doesn't have some tiled repeat texture. You have to make many quads out of a big wall segment if it's very long and very tall. So there was still some CPU work, but I noticed it was with this profiler there was some inexplicable performance loss that seemed worse than it should be still. And there are still things to fix on the polygon. So there are some good news. Yesterday I was frustrated. I was posting on our Discord. I was posting some test I did, and I also altered the profiler. You will see it more for better information. And I was frustrating with making the wall polygon a bit faster, or at least equal to the wall columns in the bad cases. And I had a heuristic method that would draw both polygons and columns. Okay, maybe I can show you. I will also show you the new profiler. And my best, when I'm testing here and I don't run on the real hardware, I have run it on the real hardware. I will run it again once. Maybe not on this video, but later for my own record. Because I have also edited Doom mode. I have edited E1M1. I have removed monsters. There are no monsters. And I have, because I want to benchmark, there is no time demo, and I prefer to benchmark certain views that are always the same so that I compare with previous results. And I have added, this is a line, here it says W1 teleport, and it teleports in this sector. And this is the new player view, teleport destination. It looks directly at the stairs, then it teleports there, then this teleports there in the green. And if I walk there, it teleports there. And then I added this one too. So I have edited this one. Thank God I'm using this, my mod loader with my own settings in Doom Builder to create my own maps for testing. And this is a benchmark. I always do. I have no default CPU and account as much as possible for cell cycles. This is a bit slower on the Phoenix is close to the real machine, but the real machine is a bit slower in how much time is spent on the cell. So before I run on the real hardware, when I want to make the most accurate benchmark, I do it here. If I care about the cell, if it's some pure CPU, here is still better because 4DO in some cases is losing its timing, especially if the cell hardware is very hungry. If you render something that kills the emulator on the 4DO, I don't know how Opera behaves with that, even if it's based on the 4DO. So Phoenix is our best to check that. And what I would do, I would say, okay, FPS, and I will check render Doom and render polygon, render Doom. 9.3. Now, this view, most of the textures are far away, and if some textures are very small, if there is a texture that takes less than 8 pixel width, or something. I don't want every one of these to be subdivided for very far pixels, so that it might be better to render columns and only for big polygons enclosed. So, and you see, if I switch, you see some of the polygons with my heuristic algorithm change. This doesn't change. There's a reason for that. I do two things. And I can improve that. But those here don't change because they are columns. These don't change. This is only the wall. The floor is still a software, and I haven't changed the floor with polygons. This was the old algorithm that I was very dissatisfied. So I put it in poly. 9.4. Okay, from 9.3, 9.4. That's better. Previously it was 9.3 and 9.3. And we go here. 9.5. This is a good case because there is staircase, and a lot of these stairs would be rendered with columns instead of a big quad. Maybe this is, if this texture is that and it repeats, it's two quads. Okay, from 9.5 to 10. That's a good improvement, and there are better improvements. In the heavy scenes, where it's very low frame rate, the improvement is smaller, but at least in those big scenes where not many I managed to get equal or most, even compared to previous. 7.6, 7.7. Okay. At least it's not worse, because it used to be, if you put the polygon renderer, sometimes you would get worse frame rate. There is only one case here. At least now it's 10.8, and if you put, see, and very few, this changes, that is closer. For some reason those change, those are made in poly. I have to see my algorithm. I might have a mistake. This shouldn't, these are too far to change. And this change. And it's, I have to see that, 10.7. I have to see why those. So here we have a loss, 0, in this open. There's a reason, because this wall is tall, although only this change, and those far away, this shouldn't. And this, you would think my polygon engine is one big quad on this wall segment. First of all, it's till this wall segment. This is a different wall. But it's really, how to say it? It's, see, if I move here, why doesn't that change? Okay, I have a, okay, that's interesting. And now it does change. This wall is so tall that you might think it's one big quad. No, it's subdivided. This texture is subdivided here, and also I think it's this one, and then it's subdivided above and above. Maybe I should have the wireframe mode to show you. So when you look from distance, there are a lot of subdivisions to even create the polygons. So it's the only case, but at least it's almost the same with slide off. So 8.0, but it can improve. Now this is the same. At least it's the same. In such big areas with big view, there is an issue. Now this is a good case with the stairs in a closed room. 13.4, 15.7. It's like, it's more than 2 FPS up from 13 to, that's good. And recently I realized, as I was moving, you go here, for example, 13.4, 15.4. Let's try many of them, and you see, I did some improvements on the heuristics and something on the polygon actually. No, oh no, I didn't change the heuristics. This is a nice view because it has up and down different wall sectors. 11.3, 11.2, 13. And you will see, if you do that, 15, 16, you put that, Still 16. There are some cases where, and anyway, you stop it somewhere, you say, okay, that's 11. 11, okay, 11.3. The light is flashing, so 11.8, okay, it's a little bit, but it's something. 15.1, 17, wow. It's so good now that I need to see why it is far away. 13.5, 13.5 for some reason. Did I change it? Maybe. This room is nice. So 12, 0. 15, from 12, 15. Look at the smoothness. And then I put Doom. You see there is a difference in the smoothness. So finally I can say, and I haven't finished with the polygon engine because I think there is more I can improve. But I made some changes that there were some oversights that make it slower than it should be. And I have to improve the heuristic, so for the cases that happen to be worse. Even views like that are very slow, 8.2, 8.4, something is gained, even 0. So I used to be, I don't know if the polygon engine is always good to put, because you might have cases that are slower. But I realized 11, 11.3. In most cases it doesn't, but you can gain from 0.1 to 2, 3 FPS and some good cases. And that's only part of the whole render. There are more things I can optimize, and there is more things I can optimize in this one too. But there is a thing. I did some changes, and here is where I'm keeping the stuff. And I have this benchmark, and I try to always run it on Phoenix and see. So those are the numbers. This is the heuristic that the closest walls will be rendered with the quad polish. The far away I switch to the columns. So most of them were like that, no improvement. There was still the drop. And this is the stairs, which is good. I recently, I thought I had it here. Ah, yeah, here. I used to have this big thing, which will switch between draw quad polygons, and it takes a whole segment. And as I said, to explain you, a whole segment can be something like here, something as big as this one. This is a very long one. Can be this big wall. But this wall has a repeating text, so I will have to subdivide it. Maybe it's one code here, one code here. You see, even this is a 32 by 1. It's a bit on a PC Doom. this texture would repeat. It goes 64 by 128. On the 3DO, to save space, and on PC this texture will repeat, and the second piece would have some extra bullet holes and other stuff. Would have a bit different texture detail. On 3DO and on Jaguar, I guess, to save, they got this piece and they repeat it. And this is repeating so many times. So this is like one, and it's repeating here and then here below. And also a third part that is half. Because the height is not 256, it's a bit longer, it's 2 times and more. So you have 3 polygons and another 3 and another 3 and another 3. So imagine how many subdivisions and how many polygons you end up having. It's a problem. But this thing is a whole segment. On the 3DO it's many polygons. On the PCDoom it's one line, one whole segment line. And here I'm looping through the whole segments. I get my whole segment pointer from somewhere. So it's the data structure Doom uses. And I'm sending it to the, okay, draw it as a polygon, which will subdivide it later to more polygons. But based on some heuristics, whole segment right minus left, I get I think this is the projected points on the screen. And I get if it's less than the threshold. When it says switch columns, don't render as polygon. Go here and render it as segment as the columns, and there is also the unshaded, of course. So there will be a flip-flop between some parts will be rendered as polygons, some parts will be rendered as columns. And I have added extra heuristic. Okay, if this is not the case, you have to do some extra check. Now those one, it does the IMU fix. I try to avoid that one, but this has to happen though, because those texts left and right are also globals that later my polygon routine. This is the texture coordinate left and right, the column coordinate. It has to read it. There's more. It has to find the length, and it has to find pixel length, how many pixels by text width divide. Oh my god, I'm doing a division here. Huh? That's also, there is also a division, which is okay. It's for few whole segments. There are a lot of things that could be improved, because I was wondering this heuristic thing might be eating some speed. I tried to replace the fix mul, but it broke everything. So there is still stuff to do. But later I added, if I comment out the heuristic polyseg, it will run this, which everything will be drawn in DrawSeg poly. Those have to be calculated, because they are used by the DrawSeg poly. I think I can improve a lot of the code here. You still have to do a lot. Now here, unfortunately, okay. This is a loop where I'm going vertically. Where I'm going dang, and see if the texture width exceeds, and if I have to subdivide in 2 or more polygons vertically. So I go horizontally. I guess when I call that, and vertically. But I discovered a trick that you didn't have to subdivide, and there was some kind of fake tiling. This is the same trick that Becky was using on the single column render, but for the single column render it works because the width is one texture pixel and it finishes before going to the next comment. That trick was weird, and I make it work even for quads. I discussed this trick before. Unfortunately, after I finished, I realized it fails on real hardware. You get a black screen on the, and I have read the docs, and I'm doing something on the CEL with this version. I'm calling the same function, but I'm giving a very long text height. Run is the total length. So this one might be from here to up here. Might be 300 something length instead of 128 of the texture. While here I have to, I still give the run. If run greater than text height, decrease. I think it was the run. I need to see. But in one, no, I was looking here. I'm giving the full text height, while here I'm giving pieces of the. This in this case would be 128, 120. This would be just take all of it. Even if the texture is smaller than what I was tricking the CEL to repeat the texture in a way. But this thing I read in the docs, this is invalid. This is exactly the thing that you should not do on the real hardware because it would lock the CEL. This is how the hardware is. And unfortunately this one, when I run it on an emulator, I reduce first of all fewer cells to send and fewer, there is no subdivision. And I got even better result, 9.4, 10.2, 10.1, 7.9. And here I had a drop with this one because I was rendering the, the many from a distance, all the subdivided polygons on the cell. And there are also many textures. It's taxing even for the texture reads that the 3DO has to do. So I had a whopping drop from 10.8 to 10.2. I saved that one to 10.6 with this trick. So it must be mainly the subdivision I'm thinking about. So it's not better, but it improves some cases that were lost. But this was all polys and not some polys. And later, I don't know if I have no CSI. And see, if on the Phoenix emulator, I don't have it now, you can disable the cycles, you get much better results. If there was no cell cycle, means. Even though you see, the work has to be done on the CPU. There is an overhead on the cell, but it's not that important compared to the most optimization you have to do is in the CPU really. And later I tried on actual hardware, but not this one, because that will crash. But I think I tried the all polys, columns and all polys, and you see it's worse. It's worse than not 9.3, 8.7. You still have the advantage on the stage from 12.3 to 14.6. You have in this one, you have a big drop. There is some gain here. I see this is the staircase. So it was at a point where the polygons were, but that was the old polish, and I thought if I use the sum polish, I would get 10.8. But I made changes. This is old. I made some changes. I used to, when I completed a whole segment, not the individual quads. A whole might be made by many quads. then I don't see it here. I would do a draw. I used to do a DrawCels down per wall segment, and I realized that I was making a lot of DrawCels calls, but so in other places though, I was keeping an array. That's what the original do. So for the polygon calls, I didn't realize I was doing more draw calls than I should. So now I have an array and I have the flash function, which is similar. So as I'm adding more polygons to the cell, I'm increasing the CCB pointer of an array. I have an array. If these are going over the maximum, I have an array of CCB that are linked together, then only flash. Now you might want to flash in more places, and I'm doing a final flash here, I see. And the thing is, in the heuristic, if you I could demonstrate maybe. You might be switching from whole columns that are using the whole columns is using. Okay, maybe open it. The whole columns are here, and I'm having again a flash, and it's a different array because the column arrays, I call it bitmap CCB. I create my own struct that are mimicking the original struct, so I have different and smaller structs because I'm wondering if I can find this bitmap CCB. This is something one can do in the future. Instead of using the CCB structure, you can make your own. Because now I have scrapped away no CCB width and CCB height, no HDDX. These are missing. This is the third vector for actual polygons, but here it's for bitmap, for sprites and columns, which they don't need them. You just have to set them to 0 for those and keep them the same. But still needs. So now I made a struct that is a bit smaller so that I save memory. It just excludes those. And my CCB was again the struct that Becky was using on the original Doom, which was already a CCB struct that was missing this CCB width and height because you don't need them. These are extra variables that were used from some 3DO libs that we don't use. Because the width and the height are incorporated in the pre-0 and pre-1 in some of the bit flags. So if you want to extract them, they are there. But they are in a format that is you have to do bit shifting. So they added the same information in extra items. So my CCB was something that Becky did, and it's basically the same as my poly CCB. So there are other places where my CCB is used because I didn't want to change the code everything, and I can use poly CCB in my place and bitmap CCB and remove even those for the columns because I do have arrays. It's again, I have a CCB array wall with some max wall. I set it to max screen width 320 because usually I can make it bigger. So I should show you something. I forgot to show. Okay, maybe I'll run 40 euros because it loads faster. Because it loads faster, I have it overclocked. Just to show you a bit fast. Even the regular one. I have changed things in the performance profiler I have shown in the previous video to help me even further. And this is what helped me see some of these issues. Maybe even put the poly, but I was searching the profile. Blank. See. So now these are not percentage, these are milliseconds, I think. And this first number is, I wanted to make sure, what if I call a certain function more times than I should? And this function is called 6 times. Depending on where you look, at the place I put it at 0 because I wanted to see this heuristic will get every whole segment that is visible. Will go from one to another. You don't know how they come. And some of them will decide, oh, I should better render this as columns instead of polygons. Or no, it's better to render it as polygons. So the far away and the ones that are very tiny, or the texture is so small at that distance that the total length is over under the threshold. So I decided between two, but because for the walls I'm using a different CCP array wall for the columns. These are the columns. I might say wall, but it's called every cell is a column, and it's a bitmap CCP. I couldn't unify them. For the polygons, I'm using the poly CCP. And this is CCP quad wall texture. The bigger quads. So with this heuristic, you would have things popping in front or back in the wrong, because it's rendered back to front, but I have to, when I have this linked list of many cells, and then I decided to do one draw call. I want to reduce the draw calls to render all of them, but if it suddenly has prepared many whole columns or many polygons and it switches from one mode to another in the next iteration, I'm checking if the render switch columns compared to the previous switch column, if it's different. And here it will render the columns, but then flash the CCP array polygon. Are the polygons, and here flash the CCP array wall. So there is this back and front, and so when you look there are 4 and 4 draw calls. Previously, the polygons were doing 21 draw calls, 30 draw calls, depending on where you look, and that's something I corrected. Yeah, it gets a lot, but this is inevitable. Else you will see things, some columns that weren't rendered before will be flashed later, and you will see popping from behind the walls popping in front. It will be totally wrong. So that's something I cannot escape, but still overall I can improve the heuristic. I can try different thresholds. I found this by trial and error, but that was before I made some changes on the polygons, and it was a bit worse because I was doing a draw call every whole segment. I was doing 20, 30 draw calls or more, but here it's reduced. And so yeah. And see, I have those star bench period and bench period, which I will use for the other thing. I have to see, really, the most important is the draw planes. We know it's the software rendering on the floor, but so, and it's not easy to optimize, and but I would have some luck with the star seg loop, because in some views this seg loop is more. Even the DrawCels is not. But we are in polygons here. Let's see. The DrawCels are 5.6 and 5.9. It's interesting to see. 2.6, 2.1. It's better with the poly. But it's not the one that is. Now the plane is receding. Oh, hold on a minute. Now, see, there are things that I have to see. Maybe. Oh, okay. Sorry. 4DO is not good. Because when you switch to polygons, it's not good. The timings are not right. If there is a change in the cell renderer, in one mode, maybe we are putting the cell through more stuff. So the emulator is slower and the timing changes with their timer. It's wrong. So Phoenix is the right thing. But anyway, I think. Oh yeah. So I had fixed that, and I would have the issue that colors were flashing. I think I saw that. See, the colors are flashing. Because the palette has not been updated. And the reason is, I was doing another trick to reduce. If you have many polygons on the screen, many cells, every cell has a palette. But there is a trick, and it really, if you don't do it, you get worse numbers on there. And I was changing things. I was like, why is it slow now? Where I have removed. I used to have this big array that I will do a draw call at the end or something like that. Or I will do a draw call per. Oh no, I would even do it per whole segment in the beginning, which was worse. But everything would have this on. No, only the first element 0 at the time, because I would increase. I would add several cells. I would link several cells, and the first one was the first polygon of a whole segment, and then I would do a draw call every whole segment, which is the thing I'm avoiding now. And back then I would, I would not. This is the flag that says to the cell, load the palette. You have to load the palette. So normally when you create a new cell, the default value is to have this, but I intentionally removed it. See, here I'm still doing the flat walls are not optimized yet for that. I could do that too, but okay. I'm focusing on the texture ones. And I would say only if it's the first element, then set the flags to that. So that the first element in a big wall that is broken in several quads, it will load the palette of the texture, and this texture will repeat, so you don't need to load the palette in every. This matters, especially if you have a lot of elements. I did this test with thousands of sprites, and it would matter a lot if you don't load the palette all the time. So that was the old time, but I would add polygons for a whole segment and then reset the index to 0 for the next whole segment. But now it's more arbitrary. You add polygons of one whole segment and you continue linking more cell later. So I had to do that at some places. No, I think it's here. Yeah, so here I'm about to render a new whole segment, a full whole segment. And this is going to repeat to tile and create more vertically and then horizontally. Gotta see that actually. Is it horizontal here? Yeah, polish count horizontal. Yeah, that's the horizontal tiling. So I would have a current index, because now I might start from 0. I might add some cells for a wall segment, and then I don't reset the pointer to 0. I continue adding, and there must be a check that says, in the rare case where from where you are plus the extra polygon, if they exceed the total max number on this array, then flash it and start from the beginning. And now flash will set this draw CCB array poly, which is here. It will do the DrawCels. That's the one that tells to the CEL engine to render. That's the critical one that you have to avoid many times. It will set the polygon, that increase in index to 0, so that the next time it starts from the beginning of the array. Since we finally flashed all the, else it will go plus polygon. It will take the pointer in the beginning of the, and it will start adding, the scale length. These are some data get from outside to know what texture to prepare. There are still how many? See, I have a lot of weird stuff here. Yeah, to prepare a cell code, you have to do a lot of stuff with the flags, to be honest. The light changes per quad. I can look at it and optimize some stuff. Maybe some of that stuff could be done outside. Few of them. There is still potential to improve it, but at least now it's where I want it to be. Like in the worst cases, it's not worse than the column, the original renderer, and in the good cases, you can get 0.5 FPS or 2 or 3 FPS in the stairs. Which it was like that before, but it's slightly improved. And the negative cases are reduced to almost equals to the column. And anyway, so I'm passing the palette here, and I'm changing the flags. I'm enabling just for this one, for the current polygon, the first polygon on the. But the thing is, I don't call a draw. I don't do a draw call here unless it reaches the point, or this flip-flop heuristic switch decides I have to draw what I had on the polygons and then go to the columns and then back. So in the initial case, because I would not do that, this is much better. I would loop through every poly CCB, and this happens to be 512. I put a good number. If you put a small number, you get flashing thing. I have to see that. Because what if you make a lever that is way more complex with all segments? This is 128. This is the maximum number of wall segments the Doom engine accept, and I multiply by 4 because I say, okay, I might have a big hole or 128 walls with vertical parts, high, 4 times high. I put something safe enough. And in the previous case, I would loop 512 times. And I would, this is, I'm removing the LD plot from the previous case, because you can't leave this. In the next iteration, while you are moving and it's rendering different polygons, It's like I'm marking specific stars with LDPlut and remove them, and I couldn't do it inside for some reasons. I could have done it later. So and I realized I was getting, when I, okay, this is the heuristic, but I was getting no, I wasn't getting that. I don't have the numbers here. I was getting that, even with the heuristic. Suddenly, when I was making this change, suddenly the heuristic started to become worse, way worse. And I was like, what the hell? Because it was doing this flip-flopping to flash the polygons, but I say, yeah, I'm still doing less flash polygon than when I was doing one draw call per wall segment. Now I might do one draw call per 3-5 wall segments, depending on how, based on the heuristic, I have to go between columns and polys and columns and polys. So I'm doing not perfect, but better. Yeah, because I was looping 512 times, which doesn't seem much, and was removing these flags from memory, and this was adding, and I was like, I was face spamming. So I'm just keeping now the few times, 5 times, 9 times I changed. I'm keeping that I changed this flag, so these are pointers to the flags now. This is a pointer. Okay, there is some extra thing that happens here, and I'm making minimal. If I OR that with LDPlut, this flag, which is here, I will keep its address so that later at the end of a flash I can, and I increase an index from 0. So that did it, and I managed to have the heuristics the way it was before, and I got, I don't have the results here. We got to 1.4. Okay, we dropped a bit, we got 10.0, but okay. This is 7.8. This went to 10.7, I think, or 6 or 7. Much better. At least it's very close, even the worst case are close. Okay, this for some reason it was 8.0. Here it was 8.0. Okay, but it is because I changed something in the teleporter, and there is an extra line. So it's not, but it stayed 8.0. And this was for 13.4. I changed the camera there to, so finally with the heuristic I have something like that, but this is not 10 point. This is not dropping 606 point. This is like that, and some of, so I'm almost close to the column case, for example. Anyway, those are, I was curious about this small, this I have to update this. Because I was doing this stupid thing, and the heuristic wasn't as good as the non-heuristic. But the non-heuristic in the big hole, it was killing it. It was bad. And you see, there are some parts of the walls that still disappear. So there are some far away walls in that view. In this view here, you can see in this window from far away, I see when I flip-flop the polys, they switch, so it switches from the column to the poly. It shouldn't do it for those far away, so my heuristic is still in trouble. Anyway, so there is a hope to, and if I now review the CPU code and since now things have changed, maybe even improve the heuristic, try different thresholds, maybe another threshold here and here. Maybe I can improve things so well that, and then I will attack the CPU code. But the real work I have to do is phase 6.1, which is the seg loop. Repair seg loop. And this is is doing things for the sprites, it's doing things, seg loop ceiling, seg loop floor. There's a lot of CPU code doing weird stuff to prepare. I kinda understand what it's doing. I could have a look at it again and see if I can improve that. Or here is the viz plane, but I realized recently with my benchmark it's not eating as much as this is not. It was taking like 3% of the performance, so it wasn't taking. It was at the beginning. I can put start bench and then bars in all of these parts and see individually which ones are killing it. So I guess if I insist, there is hope we can get some more frame performance. And I would consider many things. I'll be doing this every day. I'll be pushing it and not focusing other gimmicks. Because it's with the profiler I did, it's exciting and I can see things that I wasn't seeing. See, that's how I've seen it. Yeah, here is the old one. This is called 5 times. This was called 21 times, but at the time, not anymore. This one would do a DrawCels call, which is the cells to the 3DO API that will use the cell hardware, and it's also a SW switching between supervisor, user mode and supervisor and back, which has a great performance loss, and talking to the cell engine. I was doing a lot of calls. That's where I see it, and the performance was 7.7 from 1.3. Now, much later, I have seen this big 7 point something, 9 point something. Even if I change that, because of that other lazy way to delete 512 and change 512 flags to ldplut and no ldplut. You know. Anyway, let's not keep this longer. I'm just showing you how things are at the moment, and it's very exciting. It's very exciting, and I'm going to spend many times because sometimes you can spend time trying to optimize things, and you would be frustrated, and you would be like, "I don't think I can do anything anymore." If I make it even 5% faster, I should get a medal, a medal, a medal. And then later, if you push it, you get some some idea or some I forgot the word, breakthrough that that's my hope. You don't get 5, you might get a 30% improve. If you can make this, by the way, it seems low, but this is on max. This is full screen max, no half columns, no, it's pixel per pixel. If you want to enjoy the current OptiDoom, you can use the reduced quality settings. And but these are counted in the worst case, in the full screen, full quality rendering. That's why they are single. I wish this would go 15. I wish they would go 5%. That would be very great. The other thing I noticed, when you use the half resolution columns, sometimes you don't get the improvement with the polygon engine. Because now the columns are much fewer and things getting easier. So the polygon engine will has great advantage with the max settings and full resolution, and not the half column resolutions and small window and so on. And even the change is minimal. It's still minimal. I wish more. I can push it. I can push the other parts instead of the polys. Anyway, guys, and that's it. See you in the next video. Bye.